Everybody who has used the shortest path node knows about the horrific geometry it creates. Look at this, I mean, overlapping. This is a havoc, you know, we need to solve this. So I said, let's make it a modest, 50 times better. How do we do this? Well, we just click on this little switch here, 107,000,000 to 57,000 vertices. This works super fast. So before it took 27 milliseconds, now it takes 6 milliseconds. So with the optimization, it is actually faster as well, not just, less polygons, it is actually faster. This is an amazingly useful thing, and we're gonna make one right now. So let's duplicate all of the things in the start here, and let's disconnect the group output, and let's get going. As you see, these are our shortest paths. Of course, I'm gonna turn down the resolution to something meaningful so that we can start learning how to actually fix this. And I'm going to use, instead of this grid, a very professionally modeled object I'm very proud of, which is this. I modeled this, and we're going to use this for the bases. And if you look at the things that are evaluated currently at the output, you see 7 splines. But where are those curves, and what are we even doing here? Well, this setup here creates a shortest path to the point with the index 0 from all points in our mesh. And the point 0 is precisely here. As you can see, if you're using Blender 4.1 and you turn on attribute text, then you can see those indices, which is a very useful feature. Thank you, developers. But we cannot actually see all of those curves it creates. So let's create a little explosion node. Let's take a set position, and I want to move all the curves up so that I can actually see the things that are overlapping. And for that, I'm going to take the index of each curve. I'm going to use this evaluate on domain and evaluate this integer attribute on the spline domain. So now this gives for each curve a single number instead of giving it for each point. Now it gives for each curve. And we can see this even better when we actually connect this up into our explosion node group, put this here, node system, put this here, and I'm gonna want to move everything up by 1 centimeter. So now you can see this. Every spline has its own index, its own number, identifier in the Blender scene, and it's gonna move up 0 centimeters, 1, 2, 3, 4, 5, 6 centimeters, and so on. So I'm going to group this, and I'm gonna call this exploded view. Now, obviously, you can see that we have a lot of useless splines here that we actually don't need, like the ones in the center here. I mean, you can just, immediately tell that we don't need in any ways this curve here. But first, let's ask ourselves, why is this curve even created? This is created because the start vertices of the edge paths to curves are, true for all the vertices by default. But we don't want to do this. We actually want to only draw a line from the points that actually matter. So we want to keep the shape the same. So this is the shape we want to get. And now let's, draw over all the splines we feel are necessary for this shape to happen. Okay, so the bottom one here is obviously an important one, so I'm going to draw over this one as well. And in addition to that, this one and this one are important, or the splines that contain those points. So these are all the splines that are important for this shape to happen. And as you can see, we got 1, 2, 3, 4 splines that don't make any sense because the shape would be complete without them anyways. How do we remove them? Well, let's see what is different about those splines that we are here using, that we are not using, and those that we want to use. One of the things that we can use to select them is the fact that if I turn this curve into points like that, and we join it together with the curve, and I'm gonna hide the annotations for a moment, you see that all of the splines that we have selected, they all contain exactly one point that is not used by any other points. It only has one link. So what we should do is that we should select all of the points that only have one link and use those as the start vertices instead of something useless that is happening in between here. To select all of those points that have only one connection, well, we have a very useful node, but we're going to use another geometry to better understand this. So we're going to use this grid here that looks like that, just a 3 by 3 grid. And let's look at this from the top down. So which are the points here that only have one connection? It's this one, this one, this one, this one, and this one. So if we were to draw the paths to the index 0, which is here, only from those points, we wouldn't need any of those in-between paths, because we have those, and then we have a path from here, but we don't need this since we already draw from here. So let's select only those points. And I mean, this is pretty easy to see. This is just the points that have only one vertex neighbor, right? Because, for example, this point here has 2 vertex neighbors, but all of those that we want to select have only one. So what could be better? We just use a vertex neighbors node. But, this mesh here isn't splitted in any ways. So what we actually need to do is to use edge paths to selection. And what this node gives us is just a selection on the surface of the mesh. So if I preview the object and I preview this one, and I'm going to turn off the color opacity, you can see that all the edges that have been used for the shortest paths are, true. For example, this edge right here is false because this one hasn't been used in shortest paths. So what we can do now is we can separate the mesh based on this edge path to selection. I'm going to move these ones a bit more to this side and separate them and do... Why is this not working? Well, we have to set this to the edge mode. These are edge paths. And you can see, okay, now I see these are the shortest paths. Well, these are actually not, these are just edges and they don't have any, curve information and stuff. So they're actually pretty useless, except for the fact that from here we can now, see the vertex neighbors. And you can see that all of the points that we have selected have exactly one vertex neighbor, which is honestly awesome, because this just is screaming for the compare node to compare if the vertex neighbor count is equal to 1. And these are all true, and now we have the selection. So what I'm going to do, we create the mesh, we take the edges, and from those edges we find the shortest paths, but only from the points that have, the start vertices equal to 1, only have one vertex neighbor. This is how the setup looks. I'm going to enlarge this a little bit. What is the difference? Well, if we go here, you can see that we reduced substantially the amount of vertices. So this is a lot, and this is a lot less. Not vertices, but splines, sorry. And the same is the case for our previous geometry. So if you go here, you can see before, after. Very nice. But we still have some problems. And to illustrate them, I'm going to add a little scaling node to our explode setup. And now you can see, if I just put it to 0, I don't explode anything. Then you look like, oh, this looks fine, this looks nice. But hiding in the shadows are duplicated points or overlapping points. So how do we remove those overlapping points? Might not be obvious, but let's first think, if you were to just manually cut them off, how would you do this? I would like to keep the one that is part of the longest spline. This guarantees the best that the shape is going to be kept the same if I, keep the point that is part of the longest spline. If I would, for example, just delete this one here, we would run out of this little connection here, and this would mess things up. So what we need is, for each point group here, we need to remove the point that is part of the longest spline. And for those groups, it's pretty obvious which one it's gonna be. I think this one, and I think here also this one. So here it's a bit more complicated, but luckily Blender has a new node called points to curves, which allows you to do some pretty wacky stuff. And what is a curve? Before we go on, a curve is ordered points. You might be thinking, a curve is, like right here, like a Bezier curve, and you can, it's a curve, but this is true, but it is just ordered points. So when you have a point cloud, this doesn't have any meaning. But if you, for example, have value of like 0, 7, and 8 here, then you can connect them into a curve following this order. Or if you have like 0, 17, and 8 here, you will connect them in this order. So this is very useful because we can order them based on the length of the spline they are part of. So first we need, of course, the length of the spline they're part of. And for that, let's use spline length, which we can very nicely see here, but we don't see it on the points. So instead, I'm going to store this as the named attribute on each point, like that. I'm going to call this spline length, and an underscore would be maybe nice. I remember there was somebody who was like really upset in the comments that I didn't use an underscore. I believe it was like 6 months ago or something. So for you, you see, I'm using an underscore. Are you happy? Anyways, now we know the spline length of each point, and let's see where it is. Like that, like that. Oh, okay. On each point, we now see the length of the spline they're part of. And I mean, understandably, the top one is the shortest spline. And for each group, we want to keep the point that is the longest. So what I'm going to do now is that I'm going to use the points to curves and drag this here. It doesn't work. Doesn't work because, I mean, this is a curve that is coming in here. So I'm going to take the point, curve the points, delete this nonsense here. And now see, it has done, well, exactly what it is, it is supposed to do. It has created a curve out of all of our points, but we don't want this. We want to create curves of, those point little towers here. So we need an identificator, an ID for each group that we can plug into this group ID. And for that, I stored at the start a mesh index. Now this is just the ordinary number of each point, 0 and 4 of the original mesh. And after we create the points, the mesh index is going to be inherited by all of those points. So that now each tower has its own little, like a name or something that we can use to separate between different towers. And you can plug this into the curve group ID. And now it has gone a lot better because the curves are now, indeed created on per each tower. And you can't see them for the other ones because there is only one point. But believe me, the towers are there. We have the curves, but the order of these curves is also very important because, okay, we see 6, 7, 9, but I actually want it to be so that the end point of the curve is the point that has the largest length, the longest length. So I'm going to put this spline length attribute into the weight. And now you see it has changed in order. So the 8 is now in the bottom here because this is the longest point, has the longest length. Okay, and now we can use endpoint selection and isolate this point using, false, false, true, false, false, true, and so on. Now for each group, we have made a little selection. Now I'm going to store this as an attribute, store named attribute, and I'm going to call this an attribute called keep because those are the points I want to keep. And this is a Boolean attribute saved on each point, and this is for about it. But now I'm left with something completely, I would say scary. You started out with curves and you ended up with something like that. It might seem like a solution, like the solution is not there, you can't solve this, into the scrapyard, it doesn't work anymore. Actually, the points to curves helps us again, and if you feed right content into it. So, okay, we converted those curves back into points, again into curves, and we got something like that. No, not the same curves we had before. I think you agree with me. You don't have to look too close to perceive that. But well, we can do some manipulation here. So we want to get the same curves back, and for that we need something to identify between those curves using a group ID. So for that we have an option called the spline ID. So I'm going to take an index, and I'm going to store on each spline, a spline ID, which is just the index of the spline. And if you preview that spline ID on those points, for example, it tells you, okay, this point is part of the spline 2, 1, 0, 2, 1, 0, 2, 1, 0. And we can use this, plug this into the group ID, and bam, this is working. Now you see you have, 3 different curves. So this is, 3 times better than we had before. but still the order is definitely not the same than it was before. So for that, we need some things here. The index doesn't work. We need the order of the curve before we, manipulated it. So I'm going to store on each point the index of this point before we did any, manipulation stuff here. So I'm going to put this here, spline order, and I'm going to duplicate this spline order, put this to the weight. Bam, we got the same curves. And this looks, exactly the same. So what we can do now is just, use the keep attribute. So I'm going to take the keep attribute. Okay, seems promising, and I'm going to use a separate geometry. And I want to only select the points that I want to keep. Well, this is disappointing. This is very disappointing, actually, because you think it's going to work, you've done some, complex stuff. You think it should work, but it doesn't. It actually works, but it just has a little tiny thing we have to fix. So if you look at this attribute here, and I'm going to put on the color opacity here. You see, it's selecting the correct points that we need for the shape to be. But the thing is, it also should select this one, because this is like, a little crossway point here, and it should select this one, because if you don't have this point, then you also don't have this line here, and we only are kept with this one, which is precisely the case. So a very quick and easy solution for that is to just shift the attribute by one curve segment. So how do we do this? Well, if you just look at the index of the curve, okay, and I want to get basically a true value to be here, I can take this from here to there, okay? So I need, at the point 7, I need the value from the point 6. So essentially, this is the index minus 1. You can see, right? So let's use a node called evaluate at index. And we want to evaluate the Boolean attribute called keep at an index. And this is the most useless setup in the history of geometry. As this is the exact same thing as doing that, because for each point, output the attribute of this point. This is nonsense. You don't have to do that. But what makes this more usable is the fact that we can subtract something now from this index. So instead now it's going to output the attribute from the previous point, because we go back by 1. So at point 7, we now have the value of point 6. Should it work better? Well, it does, but well, what is that now? We got the complete havoc going on. Well, the reason why this is working, not very well, is look at the attribute again. So I'm going to actually add an integer node so that we can subtract more easily. Okay, you see, it works in this case right here. But look up here. You see, bam, we get a false value here. And also here we get a false value. So why do we get those false values there, even though it was true and we shift? Well, think about what value does this point get? Like, where should this value come from? Obviously, currently its index is 0. And if we subtract 1, we get -1. Now, this is a warning sign, if you get negative indices, it's gonna get a little bit, dirty, because Blender, you don't have negative indices. So what is going to happen is that the index, if you have indices, is gonna, wrap to the top. And basically, it's gonna pick the largest one. So in our case, the largest index is 14, and the 14 currently has a false value. So now this one also has a false value, because this -1 turned into a 14. And the same case is up here, and the index is 11, and you subtract 1, it goes to 10, and the index 10 was like here, and it had a false value. So now this one also has a false value. We have to solve this. So the problem is, it shouldn't go below the minimum index value of each spline. And well, for that, we have to know the minimum index value of each spline. Well, as you can see, it is the first point of each spline. So this is something really good of a coincidence, because we can use a points of curve node. And this one can be used to sort the points of a curve based on some weight, some logic. And by default, it uses the index, so the correct order of the curve. And at the first index, sort index 0, it gives you the first point of the curve based on those weights, and the next point and the next point and so on, and just wraps back up if you go over the amount of points. But well, this just by default gives us the smallest index of each curve. So let's take this one and let's use a compare. If our index -1 is less than the smallest point of the curve, then what? Then switch. And if this is true, if we have a problem, which you can see, all of those problematic areas are now true. If there is a problem, just use the smallest value of the curve. Don't go below it. If we don't have a problem, just use the math we do. And well, you can now see that if we subtract something, for example, the 5 is always gonna be kept here because it doesn't go below it. Okay, very nice. And now if we use this as our index where to evaluate, and we plug this here, well, you can see our curve works exactly as promised, and it has been optimized really nicely. So you can even control how much of it do you want to cut. I think this is okay. And now, let's try it works with the grid as well. I'm plugging the grid. Let's put like 100 for the resolution. And let's plug this here. So evaluate the curve. Currently we have, it's gonna explode, So we need to remove the exploded view. Remove this down here. So see, we have 13,000 control points for this curve. But without our optimization, if we just, take all of that and we turn it off and we disconnect this one, we got 1 million control points. If we plug this in, we got 350,000. And if we enable the last step of the optimization, we got 13,000. This is huge, this is huge. You can literally create setups you couldn't before because of that, the performance is finally possible. And of course, don't forget that trimming and everything works just the way it should. Everything is the same as before. You just have hundreds of times of less polygons. All right, so if you want to get this tool, you can get this from Patreon, from the first tier. And now I'm going to go back making the course, the best course, by the way. So at least that's what I'm trying to do. And if you're interested, you can sign up, and we'll see you next time. Bye.